All right, geometry. So 10.6 is going to introduce you to circles, which I'm sure you're familiar with, and then these things called arcs. Okay, and again, our pretty much our main goal of this section is to focus on what are called arc lengths. Okay, so be aware that this right here is our goal, arc lengths. Okay. All right, so first of all, parts of a circle and what a circle is. So a circle is the set of all points equidistant from a given point, which is called the center, right? So down here, this is called circle P. Notice the notation here, a circle symbol with the P. So the black circle around here, all of these points are the same distance away from P. Now that same distance is called the radius right here. So a radius is that distance from the center to any point on the circle. So yes, PC is a radius, so is PB, and so is PA. Okay, so that's what a radius is. A radius goes from the center to a point on the circle. Now, if we combine two radii together, like we are here with PA and PB, we get what's called a diameter. So a diameter is just equal to 2 radii. Okay, so again, it has to go through the center, right? It's very important. It goes through the center. Okay. So two circles are going to be congruent if they have congruent radii. The radius is the sole determiner of a circle. So if two circles have two radii that are exactly the same, then those circles are going to be congruent as well. And then a central angle is an angle whose vertex is the center of the circle. So angle APC is a central angle. So is angle BPC. This is another central angle. Okay. All right. So parts of a circle. Do not ever forget what the radius and the diameter are. Don't ever do that again in your life. Okay. So now let's talk about arcs, right? An arc, right here, an arc is part of a circle. It's curved, right? So an arc is a curved part of a circle. Now, there are three types of arcs. The first type is a semicircle or half the circle. Now, typically you need a diameter. So I'm going to kind of fudge this a little bit. I am going to connect R, P, and T together to pretend like they're a diameter. So in this picture, I'm telling you that segment RT is a diameter, which means that there are two semicircles. Now, a semicircle must be named with 3 points because you have to know what direction. The semicircle is going to start at R and end at T, but am I going along the blue path up or along the red and blue path down? Well, because there's an S here, I will call arc, RST, a semicircle. To do that, you just put the three letters RST with an arc across the top. Is a semicircle. Okay, so there we go. Now, a minor arc is an arc that is smaller than a semicircle. So we have two minor arcs in this picture. So RS is a minor arc, but so is ST. And again, it doesn't matter the order. RS and SR are the same arc. Okay. Notice I only have two letters because I know if it's a minor arc, it has to be less than a semicircle. And then, of course, a major arc would then be greater or bigger than a semicircle. So in this picture here, they have STR. So I'll do like circles. So S through T. How about I change colors? How about that? That'd be better. S through T to R. And you'll notice that it is more than a semicircle, so that is a major arc. And again, notice I followed the order, S to T to R, S to T to R. I could also have called this arc RTS. And again, I would have followed the same path, but now I'm going counterclockwise. So again, go from one letter to the next. Do not skip over letters, all that fun stuff. So those are your different types of arcs. Okay. So now, one of the key things, not to be confused with arc length, is called arc measure. Arcs are measured in degrees, just like angles are. Okay. Now you'll see that they're very much related to central angles. Now, the first thing I want you to understand is that a circle equals 360 degrees, right? So I don't care if it's one rotation here, I don't care if it's one rotation out here. This is 360, this is 360 degrees. Okay, so it doesn't matter how big the circle is. So if I want to find the measure of a minor arc, the measure of any minor arc is equal to the measure of its central angle. So right here, if I want to find the measure of arc RT, it's going to be equal to the measure of the central angle that helps form that arc or opens up to that arc. And that would be this angle, 50 degrees, the measure of angle RST. This is how you find minor arc measures. And again, that'd be in degrees. To find a major arc's measure, let me use purple. So to find arc TQR, so T to Q to R, to find that arc, typically we can subtract the minor arc from 360. So to find the major arc, we're going to take the minor arc and subtract it from 360. So this major arc, TQR, is everything but arc RT. So that's why we take everything, the circle, and subtract the measure of RT. And that'd be 310 degrees. And then last but not least, right, a semicircle, just like a what do I want to call semi, whatever. Semi means half, right? Semi means half. So it's going to be 180 degrees. All right. That's why I haven't said this, but it's very important. If you have a picture and a diameter is drawn, you identify the diameter because that creates semicircles. Okay, so that's arc measure. All right, let's keep on rolling. Okay, so just like we did arc addition or angle addition and segment addition, there's also this thing called arc addition. So if you have adjacent arcs, right, adjacent arcs, that would be like AB and BC. If you add them together, you get bigger arcs. So if you take AB and add BC, you will get the measure of arc ABC. Very simple, right? And this is all degrees, right? This is still degrees. So be aware of that. Okay. Next thing, they have the state of Ohio has a big interest in knowing similarity with circles. So we're going to talk about similarity with circles. Similarity with circles. So remember, similarity has to do with same shape but different size. So it should be no surprise that all circles are similar. All circles are similar. All circles are similar. And the reason is they're all circular. They're all the shape of a circle. So the only thing that is different about them is the radius. And it is the radius that helps determine the psi. So say we have these two circles, circle O and circle P. Well, to find their scale factor, we just compare their radii. So again, the scale factor here would be K over H. And again, that would be how we get from O to P, K over H, because that'd be a bigger number because K is longer. All right. Remember, you can think of scale factors as reciprocals. So you could also think of H over K. But again, depends what order you want to go. Okay. All right. So again, all circles are similar. Now, when two coplanar circles have the same center, they're called concentric circles. So here's a picture of concentric circles. Now, I don't like how this does the job here. H is just this radius of the inner circle. K is the radius of the outer circle. I want to draw your attention to this space here, right? That space right there is not a radius. It's not. That space right there would be the measurement of K minus H, the difference in their two radii. So be aware of that. When you're going to use a radius, you have to use the center of the circle. So keep that in mind as we go through some problems today. All right, I think I got two more slides. So this one, we've done this before already. Circumference. Circumference is the distance around a circle. This is the circle's perimeter, right? Remember, we don't use the word perimeter for circles. So there were two formulas, pi times d or 2 pi r. Again, I like to just think of it as the 2 pi r because, again, usually you deal with area and circumference at the same time. So take your radius, multiply it by 2, multiply it by pi, and you get the circumference, the distance around the circle. And now the main event. Star it up like no other. Save the best for last, arc length. So say I want to find the length of this arc AB, right? So when I'm saying length, I mean the actual distance I would walk on this arc. So it could be in inches, it could be in feet, right? The length. So you need to remember the following, right? This arc length is part of the area's circumference. This arc length is part of the circle's circumference. That's an important idea, right? So when you look at this formula to find the length of an arc, you're going to use the circumference, 2 pi r or pi d. Again, I prefer 2 pi r. That's the circumference. So to find the length of arc AB, you're going to multiply by the circumference. But you only want this part, this ratio of the circumference. So what is that going to be? Well, it's going to be the measure of this central angle, which is also the measure of that arc, out of 360. X out of 360 in my picture. Okay? So it's the arc measure or the angle measure, but it's this X. Okay? So that's all. So when you're doing arc length, my first thing is going to be find the circumference. And then the second thing is multiply by the angle out of 360. That's easy. You can follow those two steps, right? Find the circumference and then multiply it by its percentage, by the portion of the circumference that you want, which is determined by the central angle. Okay. Now, some of you might also like proportional thinking, so we can think like this too. So I'll do an or. Let me do it in red. Or you could set up a proportion. So you could say, okay, I want the arc length of AB. It's going to be out of the circumference. That's going to be equal to the measure of the angle or the arc, whatever you want to think of, out of 360. So this is also a legit way to do these problems, but I'm really going to focus on this year. Find the circumference right away, and then multiply it by the ratio of the circle. Okay, so I'm going to stop this video. There's a lot to take in. Again, this last slide was the most important, so hopefully you remember it most. We're going to do some problems, I think, in Delta Math and Edulastic. All right, so make sure you go to both places first. I think I'm going to Delta Math first. Don't quote me, though.